our first demo is going to be called Atom Models Handout. Now, when we start chemistry, we always begin with doing atom models because even though the standards, the kids do not have to necessarily know how to do all of this, but they need the background. And if you don't go through how to draw one or how to set one up, they're usually, it's confusing. So we came up with this activity a couple years ago, and we were able to get a kit, which you're going to be getting. You're going to love it. It is a really fun kit. And it comes with what you'll see on the board here. If you can look here, it's got all these little manipulatives, a negative charge, a positive, and a neutral. And then it's got different orbits, like here would be your nucleus, and then you can add your orbits in, okay? And so what we do is we start out with showing the kids, when we start learning the Bohr model, and we start learning how to draw an atom, we will give them examples like you're going to see on this atom handout here, which is in your materials, so you'll be able to do that, and it has them to practice finding the atomic number, finding the atomic mass, weight, and of course they'll always need a copy of a periodic table to use and look at, and how to read that. So what I want to do is, I'm just going to say let's do oxygen, and I'm going to do oxygen up here for you. And so if you look and you find oxygen, of course it has an atomic number of 8. So what we would do is talk about the nucleus, and then we would go ahead and you actually put 8 protons. And these magnets are really good just to use in your classroom too. You can just use them all over the whiteboard. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so then what we usually do is we say, okay, let's go ahead and do our electrons because you have the same number, positives and negatives. So we've talked about that. So then we go ahead and talk about how the first orbit can hold 2 electrons, and they're moving. The electrons are always moving, so it doesn't really matter where you put them on there. Okay, so we got 2 on the first, and then we know we'll have 6 on the second. And you can have them to be drawing this. When you're doing the demo here, I highly recommend they go ahead and draw this, and it can even be the first one on the handout that they do. Okay, and so then 6. 6. Okay, and then of course if you look at the neutrons, finding the neutrons, the atomic mass is 16.00. So I always tell the kids, whatever that is, it may not be the same amount, so you round it to 16 and then subtract the atomic number, which is 8. So then you end up putting 8 neutrons in there. And the bigger ones, you may not want to use this as your nucleus. You may want to just draw a nucleus up here because you may need more room. 5, 6, 7, 8. 7, 2, 3, 4, 5, 6. Yep, 8. You're right. You want that, okay? And then you have oxygen. So you show them. They can do several examples. You can have the kids come up and do these themselves, like get volunteers to come up and try some, and make it whole group, and do that for several days when you are reviewing and starting. Like if you do bell work or beginning work, I'll put different ones on there and then let kids come up and do it. And then what I do is I will set this out. The kids will get this and they'll be put into groups. However you decide to group. Preferably no more than 3 in a group. We were talking about how 3 is usually good, and 2, and this year is probably going to be different anyway with grouping. So you have to do what works for you and your school. And so you can have them to fill these out. What I said on here to give them some choice is that they could choose any, like in the first 3 periods, they can choose to build. Because once they start getting too big, you're going to run out of manipulatives. But you have a lot of manipulatives to start with. And so what's sitting out at the stations is a little kit. And what I do is I will put that out there. Of course, they'll have their handout. And then I go ahead and take all of the protons, neutrons, and electrons manipulatives, and I put them in cups. and then I set them at the table with their station. Now usually they share amongst like 6 people because it's in the middle. So you may have to let them actually build smaller ones or let them go in stations, vary up, like somebody else can be doing something totally different, so you can use the manipulatives more effectively. But the manipulatives, these are really great because they can't see atoms. And so they're constantly moving and everything, but it's just really good for them to get to touch it. Our kids love it. And so when they go to build it, let's just say, I'm going to do neon this time here, because if you do neon, no, I'm not going to do neon. Let me do lithium. I'm going to do one smaller. But lithium has an atomic number of 3. So I'm going to build this and then we'll zoom in a minute. Okay? So you actually would put your 3 and then 2 on the first. Okay, so the neutron number, since lithium is 6.94, you can round it to 7, so it's going to have 4 neutrons as opposed to the 3, whereas oxygen had the same for all 3 subatomic particles. So 1, 2, 3, and 4. So now we're going to pause for a minute and we'll come in and see what this looks like built. Okay, so you can see here we have built the atom of lithium, 1 atom, and here's all your manipulatives, and I put them again in cups. But when you get your kit, you're going to get a whole set of these different ones. So you can see here this whole set. Your magnets will come in a set like this, and I usually just take out what I need, put it on my whiteboard, and then when you get them, you'll see them that they're kind of like together. And you can put them together and put all their pieces together like this. But what I do is take them apart and make more groups with them. So it's up to you. And then you can just take and just divide up the number you need for your groups. Okay? And that is all for this demo.